In 1905, a young man working 6 days a week in a Swiss patent office published a scientific paper that challenged the way humanity understood light. Then, another, and another, and another. By the end of that year, he had transformed modern physics, but there was something strange about the man behind those papers. He wasn't a famous professor. He didn't have a prestigious laboratory. He wasn't surrounded by a team of scientists. He was a 26-year-old patent clerk who had struggled to find an academic position after university. And yet, while the scientific establishment was looking in one direction, Einstein was looking somewhere else. He asked questions other people had stopped asking. What if time wasn't absolute? What if light behaved differently than everyone assumed? What if gravity wasn't a force in the way humanity had imagined for centuries? What if the universe itself didn't work the way our intuition told us it did? Albert Einstein didn't change the world simply because he knew more than everyone else. He changed it because he was willing to question what everyone else thought they already knew. And that may be the most important lesson hidden inside the story of his life. Because before the photographs, before the fame, before the wild hair became a symbol of genius, there was simply a young man with a question, and he refused to let it go. The boy who didn't fit the expectation. Albert Einstein was born on March 14, 1879, in Ulm, Germany. His childhood did not immediately announce the arrival of a future scientific legend. He was fascinated by ideas, but he often disliked the rigid structure of traditional schooling. He questioned, he observed, he wanted to understand. There is a popular myth that Einstein failed mathematics as a child. He didn't. In fact, he was strong in mathematics from an early age. The real story is more interesting. Einstein struggled with an educational system that emphasized discipline, memorization, and obedience more than independent thought. He wanted to know why. Why does this equation work? Why does this rule exist? Why must things be done this way? That habit would eventually become the foundation of his scientific thinking, and it appeared surprisingly early. Around the age of 16, Einstein was already fascinated by a question that seemed almost impossible. What would it be like to travel alongside a beam of light? Imagine moving beside something traveling at the fastest speed nature allows. Would the light appear frozen? Would you see a stationary electromagnetic wave? Einstein couldn't make sense of it. The question stayed with him for years. It was not yet a theory. It was simply a problem he couldn't stop thinking about. And sometimes that's where discovery begins. Not with an answer, with an unanswered question that refuses to disappear. Meanwhile, Einstein's family faced financial difficulties. His parents moved to Italy after their electrical business struggled, while Einstein continued his education elsewhere. He eventually enrolled at the Swiss Federal Polytechnic in Zurich in 1896, studying to become a teacher of mathematics and physics. He graduated in 1900, but the career he imagined did not immediately happen. He wanted an academic position. He wanted to teach. He wanted to do scientific research. Instead, he struggled to find a university job. So the future Nobel Prize winner did something surprisingly ordinary. He found another job. Not at a university, not in a laboratory, at a patent office. In 1902, Einstein began working at the Swiss Patent Office in Bern. And that ordinary job would become one of the most extraordinary chapters in the history of science. The patent clerk who was thinking about the universe. The work was technical. Einstein examined patent applications and evaluated inventions. It was paperwork, routine, precise, ordinary. But when the workday ended, Einstein returned to the questions that fascinated him, and one question was still waiting. Light. The question from his teenage years had not disappeared. Imagine chasing a beam of light. If you could somehow travel alongside it, what would you see? Would the light appear frozen? Would you see a stationary electromagnetic wave? Einstein couldn't accept the idea. He kept thinking and thinking and thinking. He wasn't building enormous machines. He wasn't surrounded by assistants. He wasn't conducting expensive experiments. He was imagining. He was using thought itself as a laboratory. This became one of his greatest intellectual tools, the thought experiment. Einstein understood something that many people overlook. Sometimes progress doesn't begin with a new answer. It begins with asking a better question. Then came 1905. Einstein was still working at the patent office, but that year would become known as his annus mirabilis. His miraculous year. He published 4 landmark papers. One explained the photoelectric effect, one analyzed Brownian motion and provided important evidence for the atomic nature of matter, one introduced special relativity, and another established the relationship between mass and energy. E equals mc squared.
The Nobel Prize later recognized Einstein, especially for his work on the photoelectric effect, not for relativity. He was awarded the 1921 Nobel Prize in Physics, which was formally presented in 1922. 1 year. 4 major scientific contributions. A 26-year-old patent clerk had forced physicists to reconsider some of their deepest assumptions. But there was something even more remarkable. The question that had followed Einstein since he was 16 was finally beginning to find an answer. And that answer would challenge one of the most fundamental things human beings thought they understood: time.
The man who challenged time. For centuries, time had seemed universal. 1 second was 1 second. 1 minute was 1 minute. Time appeared to move at the same rate for everyone. Einstein challenged that assumption. Special relativity showed that measurements of space and time depend on the observer's motion. At extreme speeds, time does not behave the way everyday experience suggests. The idea sounds almost impossible, and that's precisely what made Einstein's thinking so powerful. He wasn't asking, how does the universe fit my intuition? He was asking, what if my intuition is wrong? That distinction changed everything. But Einstein wasn't satisfied. Special relativity had transformed our understanding of motion, space, and time. Now he wanted to understand gravity. And once again, the breakthrough began not with a machine, but with an image. Einstein imagined a person falling freely. For that person, while falling, the sensation of weight could disappear. Floating and falling could feel remarkably similar. Einstein later described the insight behind this idea as the happiest thought of his life. Inside that thought was a radical possibility. Gravity and acceleration might be deeply connected. Turning that insight into a working theory would take years. And this time, imagination alone wasn't enough. The mathematics became difficult. There were dead ends, mistakes, frustration.
Competing approaches. The elegant picture in Einstein's head had to survive the brutal discipline of mathematics, but he kept going. In November 1915, Einstein presented the field equations of his general theory of relativity to the Prussian Academy of Sciences. The theory was published in its completed form in 1916. His proposal was extraordinary. Gravity wasn't simply an invisible force pulling objects through empty space. Matter and energy affected the geometry of space-time. The universe itself had structure. Space could curve. Time could be affected, and light itself could follow that curved geometry. But there was a problem. A theory this revolutionary needed evidence. Einstein had made a prediction. Now, nature had to answer. When the world discovered Einstein, in 1919, astronomers were given a rare opportunity. A total solar eclipse would allow them to photograph stars appearing close to the sun in the sky. If Einstein was right, the sun's gravity should cause their apparent positions to shift because the path of their light would be deflected. Arthur Eddington traveled to Principe, an island off the west coast of Africa. Another British team traveled to Sobral, Brazil. Frank Dyson coordinated the effort from Britain. The goal was simple: photograph the stars, measure their positions, and compare the results with Einstein's prediction. The observations were announced in London on November 6, 1919. The results were widely interpreted as supporting Einstein's theory. Newspapers around the world exploded with excitement. Einstein was suddenly famous. The patent clerk had become a global celebrity. The man who once struggled to find an academic position was now being photographed everywhere. People wanted to hear him speak. They wanted to understand his theories. They wanted to understand the strange man behind them. But this is where the story changes, because fame does something strange to human beings. It turns complicated people into simple symbols. Einstein became the wild hair, the absent-minded genius, the equation, the photograph, the celebrity scientist, the myth.
But behind the myth was still a human being, and history was about to become much darker. By the early 1930s, Germany was changing rapidly. The Nazis rose to power. Einstein's Jewish identity became a target. His scientific work was attacked as Jewish physics. His name was placed among enemies of the Nazi regime. His property was targeted. His writings were included among works condemned and burned during the Nazi campaign against un-German literature in 1933. Einstein was outside Germany when Hitler came to power. He realized he could not safely return. He renounced his German citizenship and ultimately settled in the United States. In 1933, he accepted a position at the Institute for Advanced Study in Princeton, New Jersey. Think about the distance he had traveled. A boy who didn't fit comfortably into the school system, a young graduate unable to secure the academic position he wanted, a patent clerk working in Bern, a physicist whose ideas transformed modern science, a global celebrity, and now an exile. But the story wasn't over, because even after Einstein had achieved almost everything the world could offer a scientist, there was still one thing he couldn't obtain: certainty.
The genius who never stopped questioning. There is a temptation to look at Einstein's life and reduce it to intelligence. He was brilliant. He understood mathematics. He revolutionized physics. He became one of the most famous scientists in history. So we assume his greatest advantage was simply his brain. But that explanation is incomplete. Einstein's extraordinary ability was not only that he could solve difficult problems, it was that he was willing to question the assumptions underneath them. He imagined riding alongside a beam of light. He imagined a person falling through space. He questioned the nature of time. He questioned gravity. He questioned what light actually was. He didn't treat established knowledge as sacred. And perhaps that was his greatest strength, because knowledge tells you what humanity already understands. Curiosity asks, what are we missing? That mindset also explains why Einstein remained dissatisfied even after becoming famous. He could have protected his reputation. He could have simply repeated what had already made him successful. Instead, he continued searching. He spent decades trying to find a unified theory that could bring the fundamental forces of nature into one framework. He never completed that goal, and that matters, because the story of Einstein isn't a story in which the genius gets every answer. It is a story about someone who remained willing to search when the answer refused to appear. He also challenged aspects of the emerging quantum theory, engaging in famous debates with physicists such as Niels Bohr. Didn't always win those arguments. He didn't solve every mystery, but he kept thinking. He kept questioning, kept searching.
And perhaps that is the part of Einstein's story we should remember. Not the hair, not the equation, not the photograph. The willingness to remain intellectually uncomfortable. Because the easiest thing in the world is to accept reality exactly as it appears. The harder thing is to look at something everyone considers obvious and ask, what if we're wrong? What Einstein actually teaches us. History remembers Albert Einstein as a genius, but the word genius can sometimes make achievement feel unreachable. It creates the illusion that extraordinary people were simply born differently. Einstein's story suggests something more useful. He was curious. He was persistent. He was willing to think independently. And he was comfortable spending years, sometimes decades, with questions that had no immediate answers. His greatest breakthroughs
didn't begin with certainty. They began with doubt. What if time isn't absolute? What if light behaves differently than we imagine? What if gravity isn't what we think it is? Those questions eventually changed humanity's understanding of reality. But the lesson isn't really about physics, it's about how we think. Maybe the greatest danger isn't being wrong. Maybe it's becoming so afraid of being wrong that you stop questioning anything. The world often rewards people who can repeat what everyone already knows, but progress sometimes belongs to the person willing to ask what everyone else stopped asking. Einstein's life reminds us that being different isn't automatically
a weakness. Sometimes it's the beginning of discovery. So the next time you feel like you don't fit the system, don't immediately assume something is wrong with you. Ask a better question. Maybe you're not failing to fit the world. Maybe you're looking at it from an angle no one else has considered yet. Because Albert Einstein didn't change the world by knowing everything. He changed it by refusing to stop asking questions. And perhaps the most important question isn't how intelligent am I? It's what am I still willing to question? Because your biggest breakthrough may not come from learning another answer. It may come from having the courage to challenge the question everyone else has already accepted. If Einstein's story made you look differently at your own potential, you're exactly where you belong. Subscribe to Wisdom Everflow for more true stories from history that don't just inform you, they challenge you to see yourself differently. Until next time, keep learning, keep questioning, and let wisdom ever flow.